As a co-host.
A very good evening to all in this second session of AT Atal Online Faculty Development Program, which is based on recent trends in semiconductor devices, modeling, and circuit technology. I, Praveen Kumar, and I have the honor to introduce our expert for this evening session. It's my pleasure to introduce Dr. Vaibhav Neema. Dr. Vaibhav Neema is Associate Professor in Electronics and Telecommunication Engineering Department from IET, Devi Ahilya Vishwavidyalaya, University, Indore. He received his PhD from Devi Ahilya Vishwavidyalaya, University, Indore in year 2012 and MTech in Microelectronics from Punjab University, Chandigarh in year 2003. His
म्यूट तो
specializations
रिकॉर्डिंग कर
are
दिया सर
security and
कर दिया
reliability
ठीक
of digital circuits, Internet on Things, low power VLSI system, and memory design, innovating teaching methods. He has more than 20 years of teaching experience and 15 years of experience in research area. Dr. Vaibhav is committee member of VLSI Society of India, Madhya Pradesh, co-editor member of Journal of Nanoscience and Quantum Physics, senior member of Universal IoT Society. He also received awards like Award for a Smart Traffic Idea for a Smart City project for the Best Poster Award in ISE 2016 at IIT Indore. Now, without delay, I would like to invite our expert, Dr. Vaibhav Neema, to share their invaluable experience with us. We are eager to hear their insights and the lessons they have learned along the way. Over to you, sir.
Thank you, Praveen. Thank you. Am I audible, Praveen?
Yes, sir.
Yes, sir. Yes, sir. You're audible, sir.
Thank you so much, Praveen. So, is the slide is visible?
Sir, yes, sir. Slide is visible, sir.
Okay. So, good afternoon. Thank you, Abhishek, and thank you, Praveen, for inviting me for delivering a expert talk on in this program of 6 days Atal programs. So the topic which we'll discuss in this session, I think this is last session of this program. So the topic is hardware security from the circuit point of view, hardware security and reliability basically from circuit design point of view. So mainly the major task, major softwares are there, and major softwares have a issues, and that issues we generally consider to be viruses. But because of the few incident that has occurred and that awake the industry of hardware also, okay, there may be hardware trojans or hardware attacks are also there. These are some few hardware, very famous hardware attacks. And recently you have seen the pager attacks in Lebanon, which was occurring around November this last year. So the pager attack means the pager is there, and because of the some message that received, and because of that message, the pager is getting a blast, and because of the blast, there is a no means a very less lots loss of life, but there is a means there is a consideration that there may be possibilities now. The next generation of war is not with the weapons and not with the nuclears. There may be because of this electronic system design. So this will give you the picture that how inside we are in your country. So if there is a pager attacks, means how inside we are in the country and how we can control your all the components, all the electronic systems. So that is the importance of hardware security. Some other hardware trojans that were identified in 2021, 23, and 28. Mainly this hardware security, hardware presence comes into the picture in year 2011 when there is a war between US and Afghanistan. So because of this war, there is uh, a communication system was set up by China in America itself to gather all the secure information that they consider to be side channel attacks. And because of the side channel attack, whatever the strategic planning are there, they can use that planning. They can hear that planning. They can have before to take any actions. They have an idea about that, so they can recover from there. So these are the some pictures of hardware attacks. So this hardware attacks is mainly called as a hardware trojan. So in this lecture, we'll try to understand what is a hardware trojan, how this hardware trojans occurs, how to means avoid this hardware trojan, how to design the systems or systems so that they must be free from the hardware trojans. So earlier in this era, we have various circuits with the different verticals. The verticals means what we required that the design should be as small as possible. Design should consume less energy. Design should be as fast as possible. A new is now coming up, that is to be a design should be a secure design. So whatever design you have, whatever the instrument you have, whatever your personal devices you have, that personal device should be a secure, not from the software point of view, but this is from the hardware point of view. So how you make your design secure. So we'll try to learn that, how to make your hardware secure, how to make your hardware reliable. Reliability is again an important issue with the hardware circuitry, as we're miniaturizing the transistor size to get a more and more functionality on the same piece of silicon. So reliability is again of major issues for the designers. So in today's this 1.5 hour talk, we'll discuss what are the hardware security issues are there, how to overcome with these issues, how to control, how to design a system so that the system should be a hardware trojan. It can be is prone to hardware to bear a hardware attacks, and that should be a reliability. Reliability should be there. So what is hardware trojan? So first we'll try to understand what is hardware trojan, because we have learned so many things in early stages to be a software viruses. When we have antiviruses, various antiviruses that capture the virus in our system and they clean their virus. And it is easy to clean the virus if the viruses get into your software. But it is very difficult if you have a virus in your hardware. It is very difficult to identify that virus in a hardware. It is very difficult to design our system that is to be prone from the hardware. So that is to be a hardware trojan. So how to define a hardware trojan? So it's very close. The definition is of hardware trojan is any addition or modification to a circuit or a system with the malicious intention. So if you add any, or if you modify in a circuit design, means you have a design, and if you add an extra component or if you add extra wire, and that the intention of adding that extra wire or extra gate or extra circuit, extra block is for the malicious intention, then that is known to be a hardware trojan. So what are the characteristics of hardware trojan? The characteristics of hardware trojan is malicious goal. And what are the basic uh, properties of the hardware attack? The hardware trojan is that key. It change or control the functionality. That means you have a circuit, it changes the functionality of the circuit, or it changes the control of the circuits, leak the sensitive information, or reduce the circuit reliability. So these are the major malicious goal of hardware trojans are. The hardware trojan can change or control the functionality of your circuits. You have your circuit, and with the help of if the hardware trojan is there in your circuit or your design, that maybe a functionality can be changed, means it perform a enormous functionality, or the other part is that the functionality remains the same, but it leaks the sensitive information. You have the sensitive information, it may leak that sensitive information with the help of different parameters, or it reduces circuit reliability. So the pager attack is an example of the reduced circuit reliability. So the intentionally additional modification is generally known to be a hardware trojan. So this is a very basic definition of the hardware trojan. So once I'll repeat that the hardware trojan is only the addition and modification of a circuit or a system with malicious intention. If your intention is malicious and if you add any component or extra wire in a design, then that is known to be a hardware trojan. Then the example of trusted integrated circuit in hardware trojan. So we'll try to understand the hardware trojan with the help of a simple example. The example is that Alice asked the Bob to design a circuit that computes the f of x so she can authenticate the x f of x pairs as a username and password. So what the Alice wants Bob to design a circuit. That circuit will have 10 users. The users number is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the password of each user is f of x. Is the user, if the user 0, the password is 0. For the user 1, the password is 1. If user is 2, the password is 4, and for the user 9, the password is 81. So suppose in your company you are dealing with the financial matters, and you have in your company you have a 10 users. So you assign a unique username to the each user, and their password is a square of that. So you have to design that system. So how to design that system? So Bob started designing, and because we have a 9 users in us, because we have a 10 users in our company, so to represent the 10 in digital format, we require to be a 4-bit of inputs. So we consider the x1, x2, x3, x4 are the inputs. So the inputs are from 000 for the user number 0. The binary input is a 000, and for user number 3, the binary input will be the 0011. And the password is output. Output is a password of that each user. So for the user number 9, the password is 81, is square of that term. So the to represent the 81, we require to have a 7 bits. So we need to get 7 bits of information. So Z1 to Z7, Z1, Z2, Z3, Z4, Z5, Z6, Z7 are the output information. So we have a 4-bit of input and 7 bits of output. And the output, and what is the relation between the input and output? The input is of 4 bits, is a 0, 1, 2, 3, 9, and the square of that input is to be output. So if I start to design this type of structure, so what I require to be a designer through table first. So how to write the truth table first? So the first x is representing the username, and x square is representing the password. So for the user is a 0, we have the password is 0. For user 1, we have the password is 1. And Z1, Z2, Z3, Z7 is a binary conversion of that number. So suppose we have a user number 2. So the binary input of the user number 2, x1, x2, x3, x4 is 0010. And the output is a 4, the square of that term, that is to be 0000100. So as we first draw the truth table, for the user number 9, means the 10th user, the user number is 9, and his password or his or her password is 81. So for 9, we represent in a binary form. It's to be x1 to x4. It's a 1001, and the password is 81. That is represented by the z1 to z7. It's to be 10100001. So this is a basic truth table, and when we design any VLSI system or any digital systems, first we draw the relation between the input and outputs. Once we get the relation between the input and output, we solve the k-map for the each and every outputs. Means here we have to solve the 7 k-maps. First k-map is for Z1, for Z2, for Z3, for Z4, Z5, Z6, and Z7. We solve the k-map and we identify the Boolean expression, the relation between our input and Z1 term, the input and Z2 terms, as the inputs and Z7 terms. So we write a 7k map, we solve the 7k map, and we have the design of the circuits. So before to start to making a k-map, we can have some clues in the circuits, and that is to be a easier part of the circuit. We can see here that the Z1 and X1 are the same. You can see the Z1 and X1 is at the last two for the input 8 and input 9. The X1 is 1 1 and Z1 is also 1 1. Otherwise, the X1 and Z1 are the same value 0 0 0 0. So the X1 and Z1, so means the X1 and Z1, the output Z1 is directly connected to the X1. So first we need not to solve any k-map for the Z1. Same for the Z6. The Z6 for all time, the Z6 is always to be 0. For all input values, the Z6 is 0. Means we can directly connect the Z6 with the ground line. So that again, no need to solve the k-map for the Z6. For Z7, again, the Z7 is the same as a X4. We can see that the 0 1 0 1 0 1 0 1, the same pattern you can identify for the input X4. So we can connect the Z7 with the Z4. Now remaining terms are to be Z2, Z3, Z4, Z5. So we can easily write the k-map for the Z2, Z3, Z4, Z5, and we can easily identify the circuit. So this is the circuit which after solving the k-map, we identify for the Z2. Z2, we identify that it's to be X2 into X3. For Z3, we identify as a X1 plus X2 into X4 plus X2 X3 bar. For Z4 we identify as X2 XOR of X3 into X4. for Z5 and for Z6. And Z6 as we connect to the ground, because all time the Z6 is 0, and Z4 we directly connect with the export because it's short, and X1 we also connect with Z. So this is the circuit we identify from the K-map and the general observation, and we design the circuit. So this circuit is working perfectly. If we test this circuit, if we test with the circuit, then for the user number 10 means extra users. We have in a company is only the 10 users, so you assign the username from 0 to 9. But if user number 10, unauthorized user, wants to enter your system, then if we calculate for input 10 with the help of this Z1, Z2 formulas, then we identify that is the password is equal to 68, and 68 is not a square of 10, means we will not allow this user to enter in your system. So it's perfectly working. For user number 11, if the user number 11, the 11 key is 1011. If we solve this equation for the 1011 and we identify that from the Z1 to Z7, then that is equal to the 89. 89 is not a square of 11. Means again, the 89 is to be not a valid user for your system. So this system is working perfectly without any virus, without any changes. So it allowed to enter only the 0 to 9 users with their password. For user number 10, user number 11, 12, 13, 14, 15, which are considered to be don't care condition. And for each and every don't care condition, the output, the password which is generated not to be a square of that value, means it will not allow to enter any other user inside the system. So the system is working perfectly, and this is the hardware. Now attackers, the hardware attackers, as we are talking about the hardware attack, simply change a connection. Here you can see that in Z2, earlier we have X2 and X3, this wire. You can closely look at this wire. This wire is, here we have the Z2 is to be a X2 into X3. So here we have the X2 and we have the X3. So they are AND gate, they are performing the AND gate. But now if I change the position of the wires, now if I only change the X2, we are not getting the X2 from this directly, we are getting the X2 from the output. Now if I change the X2 into X3, earlier the expression is X2 into X3, now the expression is X1 plus X2 into X3. So the expression is changed. What is the consequences of this expression, change in expression? We can see in a truth table. Here, you can see that if I only change a single connection, if I only change a single wire connection in a system, then this system is now allowing the extra user number 10, with perfect square of that number is to be 100. From this expression, from this you can calculate the Z1, the value of Z1, Z2, Z3, Z7, and you can identify that the extra user number 10 is also be an authorized user to access your system. For 11, you can see that for 11 also, 11 the password is 121. If you solve this equation for the term 1011, you will get this output, and the equivalent decimal of this output is to 121, and 121 is a square of 11. Means what? Means you are allowing the extra user in a system. Earlier the design was perfect, earlier the design was this, but somehow when you send this design for the fabrication at the time of fabrication, they have intentionally changed the location of wire. As they change the location of wire, because of this extra wire, not the extra connection, because of their only the reconnection of this X2 input, now this system will allow the other user to enter in the system. So this is known to be a hardware closure. So any addition of wire, extra wire, that allow the unauthorized user to enter your system, that is to be a hardware intrusion. This may be the intention of malicious cause. It may be intention that, okay, once you allow this user to enter your systems, it is so it capture all the data, or it hang your systems, or it will recover all the sensitive information from the system. So that is to be a hardware Trojan. I think this is clear from the example. What is a hardware Trojan? The hardware Trojan means the definition, as per the definition of the hardware Trojan, if intentionally, with the malicious intention, if you change the position of the wire, and because of the change in the position of wire, the unauthorized user can access your system, then that is known to be a hardware Trojan in the system. This is one of the example of hardware Trojan, how the hardware Trojan impact or how the hardware Trojan get into your system. We'll take the one more example of the hardware Trojan. That is very simple example. The example of your PIN. Suppose in your mobile, if you have a phone pay or if you have a your Paytm, then you insert your PIN, or even in your mobile screen, when you uh, for your system or for your mobile, you have to put your PIN number. Once you insert a correct PIN, then only this mobile will allow to access, or then only the system will allow to access. So how this PIN number will work? The PIN number means there is a continuous sequence. It may be the sequence of 4 continuous digits. It may be the sequence of 3 continuous digits. It may be the sequence of 4 continuous digits, or it may be the maximum is to be a six continuous digits are there. And if you enter the correct digit one by one, then only the system will allow it to enter into the system. Otherwise, it will reject your request. So that is, if we understand or if we try to understand this designing in for the pin generation, that is based on finite state machine. So you can design such kind of system with the help of FSM, that is known to be a finite state machine. There are two types of finite state machine. One is to be a Meray model, or one is to be a Moulin model. So you can use any model for a synchronous or synchronous circuit designing. Here we consider a simple example where we have the three states: state 00, state 01, and state 10. So if you are in state 00, and if you enter the 0, means supposed to be a first pin. If you enter 0, you move to the next stage. Next stage is to be 01. And next, the next, you press the 1. Then you allow to enter to the next state, that is to be 1, 0. Then next, your key is to be 0, then you remains into the state. It may be the 3-digit pin code, or if maybe the 3-digit secure code. If you enter into this state, then only it allowed to enter into the system, actual system. So your secret key is 010. Your secret key is 010. At any stage, suppose you first write a 1, means if you're not allowed to enter into the system. Suppose you enter the first correct key as a 0, and the second correct key is 1, but instead of entering a 1, you enter a 0, then it will not allow to enter into the system. Means it reject your request and go back to the first system issues. So this is to be a pin generation or pin identification. So it's a 3-bit pin identification, or it can be a single pin identification, that is known to be shortcut keys. And from the 00, if you press a 1, you can directly go to the 10 states, and 10 you go to the 0. If you press the 0, you remains to the this state and that final state. So this is a dynamic key generation where we have a 3-bit key and we have a 2-bit key. We have a 2 paths. The one path to enter into the system is with the key number 010, and the second shortest path is to be 10. If you know this path, if you know this keywords, passcode or keyword, then only you can enter into the system. Now you have this state diagram. This is known to be state diagram. From the state diagram, we write a state table. And from the state diagram, state table, we design a circuit. Suppose this combination circuit we design. Suppose this is a circuit we have designed. This is a circuit we have designed. And if I redesign, if I rewrite this table, that is to be excitation table or state table, then this table has a 2 extra states. You can see here, this table has a 2 extra states. It has an extra state, this circuit. First, what we consider, we have this state diagram for the pin generation. From the state diagrams, we first generate a state table. From the state tables, we generate the state machine, state hardwares. Now, in the second phase, we again draw a state table from the generated hardware. If I generate a state table from the hardware, then it will give me these 2 states. These are marked in a red color. These are additional states. We do not require for our systems, but because of this hardware design, they are coming into your state diagram, state machine or state table. What stage we have? We have a 01. 01 means if you are at this stage, and if you enter the 0, then you can go back to the 00. This branch is not there in our original hardware, your pin code. But because of the hardware design, because of the don't care conditions, these two states are come into the picture. So this may be the entering state for a undefined user in your systems. Means if otherwise if you press a first keys to be 0 and second key is a 1, then only you can access to the third stage. But in this case, if you enter the 0 and if you again enter the 0, the wrong key, it remains, it restarts your design. So that not should be that should not be done. Otherwise, it will, you can go to the short key, you can go to the other statements. So this will not require, but because of the hardware design, because we have not considered the don't care condition in the system, this system will generate this type of state table. We require this, but the generated state table is this because of the hardware limitations. Next, we can see that. Apart from that, this system also have two invalid states, 1 1 and 1 0. If from this hardware we try to get the output of this state, if we are at the unknown state 1 1, and if we press the key is a 0, then you go to the 1 0. 1 0 is your final stage. You can go to the 1 0 state, that is to the final state. Means you can, if you press a wrong information, if you press a wrong key, either though if you're at the unwanted state, you can enter into the system with this key generation source. Same if you are at the 1 1 unwanted state, and if you generate the 1, it will allow to go into the reset state, that is to be 0. So this red mark color states are not required for the system, but because of the don't care condition and because of the limitation of the hardware, this states comes into the picture, and this will allow what the output and what the consequences of this output. Now you want this state diagrams, state table, but the actual hardware, actual state diagram is this. This will allow to have a one extra state, that is to be 1 1, and this state is allowed to go to the final stage, or it will allow to restart your system with 0 0. So this is this gives the other free hand to the hardware Trojan attackers to get into the secure chip or to get into the secure hardware. So what is the output of this? The hardware Trojan horse adding the hidden access to the 0 0, means the hardware Trojan horse is there. It adding a 0 1 1 state. It allowed to enter into the 0 0 state, means it allowed to enter into the systems. Once you enter into the systems, either you press a 0 or either you press a 1, you can get the next state, and either you press a 0 or 1, it will give you the final state. Means without entering into the positive key, if you are starting with the 1 1, and you can easily get into the final stage of your system. So that is to be a hardware Trojan. So if you change the hardware, if you are not considering the don't care condition in your system, then this don't care condition will allow the hardware users or hardware attackers to attack into the systems. Okay. So the findings, the backdoors. This is known to be backdoor. Who can reach to the state 0 0 required as to be 0 0 nil, means in the first stage, because it's a starting stage, so they are not allowed to enter into the 0 0 states. But because of the design from 0 0 0 1 1 0 and 1 1, you can easily go into this design at this stage, because this is dangerous. If you are starting the states is wrong, so if you enter a password with the starting stage to be 0 1, you can easily enter into the system and you can easily change the information inside the system. So that is to be random walk. This kind of attack is called to be random walk attack. In the given design system, start from the random states. We start with the random states. Give a random inputs. Whatever the inputs are required, you can give a 0 random input or 1 inputs. If the new state is to be 0 0, successfully you break that attack, and otherwise go to the next stage. So this is called to be random walk attack. It's a kind of hardware attacks that is generally used to crack your PIN numbers, your PIN code for the ATM, PIN code for the ATM, PIN code for system, PIN code for mobiles. If you want to access unauthorized, means if it's required to access unauthorized user to access your system, then they can use a random walk attack. It's a random walk attack. In the random walk attacks, the unidentified states are used to be entering a state for the system. Here, for example, in this case, A 1-1 is a unwanted states. This is not allowed in a design. But because of this reason, you go into this 1-1 stage, and from this 1-1, you go, if you enter a wrong key as a 1, you go to the initial state, that is dangerous, or either if you press a 0, you can go to the final state, that is to be 0 state. So this allow to enter into the initial stage, or this will allow to enter into the final stage also. So this is a crack of your system. It crack your pin and it can enter into your systems. It may be give your means recover your secret information, your password, and all this, and that is to the hardware attacks. So we understand this hardware attack two examples. The first example is of a combination circuits where we have designing part, and the second we have a pin code identification, that is known to the random walk attack. The random walk attack is generally used to get to identify your pin numbers, your pin, ATM pin, your passport pin, your password pins, where the digits are there. Suppose that is your secret locker is there. In the locker, they have 8 key digits, 8-bit secret code is there. If the random walk is there, the random walk, if you apply the random walk attack, then they can easily get into your locker and they can easily identify your systems. So that is to be a hardware Trojan. So trusted integrated circuit means without a hardware Trojan, can a circuit to be a trusted integrated circuits? So trusted integrated circuit, how to define the trusted integrated circuits? Earlier we defined hardware Trojan kind of systems. Now we try to define a trusted integrated circuit. How to define a trusted integrated circuit? A trusted integrated circuit does exactly what it is asked for. No more, no less. In this case, this circuit is only required to have a 3 stages. But because of the hardware limitation, hardware design limitation, we have other stages. So that is, it is not a perfect system. It is not called to be trusted integrated circuit because this has a extra images, extra wire or extra states. That state will allow that can be used by the hardware attackers to enter into your secure system. So this is known to be trusted integrated circuit. So what is the definition of trusted integrated circuit? And a trusted integrated circuit does exactly what it is asked for, no more and no less. जो काम दिया है वही करे, उससे न ज़्यादा उससे कम. That is known to be trusted integrated circuits. Example of untrusted integrated circuit: fail to deliver certain required functionality. In some cases, we have seen in the first example, it is not a fail to deliver certain requirement functionality. Means we require that for the user number 10, it will not allow to access the user number 10, 11, 12, 13, 14. But because of the functionality change in functionality, it allows the unauthorized user to enter in your system. Have the hardware Trojan inside the chip systems? We have seen in the second example that the hardware Trojan is there, and because of the hardware Trojan, because of the extra state, this state will allow to enter into your secure system. So these two is example of untrusted ICs. So this kind of design, which we have used in example number 1 and example number 2, this kind of integrated circuits are mainly known to be a untrusted integrated circuit. The untrusted integrated circuit means integrated circuit which are having the hardware Trojan inside there. Chip and system is known to be a untrusted integrated circuit. So the question, the big question is that does such systems IC exist? Trusted integrated circuit exists. It is very difficult to say it in a definition, but as per my definition, no less or no more. If you're asked to design a system with the 3 states only, then you have to design a perfect system with the 3 states only. You have to consider the don't care condition. You have to design your system with the don't care condition. Means you have to consider the don't care condition, and from the don't care condition means you just not leave the don't care condition is to be XXXX. The don't care condition can be used by the hardware attackers is to get into your system. So you have to design, you have to perfectly design your system so that if you ask to design only the 3-state 3-pin system, that it's to be a 3-pin system, not for the 4-pin or not. Means you have not put any space for the designer to enter into your system. Exactly what you required, you should design that system. Mainly what we do earlier in this example, why these attackers is easily find this location, because the 4 bits of inputs are there, and the 4 bits of input means we have 16 combination, but out of the 16 combination we are only using the 10 combination. So in generally, we only consider the 10 combination. We only consider the 10 combination. We design the KMF for only this state combination. Otherwise, we consider the other users to be don't care. If we consider the other user to be don't care condition, don't care users, then that is a bigger mistake for the various designers. That will give the space for the hardware attackers to attack into the system. So when you design your system, you perfectly consider all the states of your systems. Please don't leave any space for the don't.
Hello.
Hello, yes. Hello, hello, hello. Any question?
Hello.
Hello, yes. Hello. Am I audible to all? Abhishek?
Yes, sir. Now you are audible, sir. Yes, sir. Yes, sir.
Some miscommunication is there.
No, no, no. It's fine, sir. It's fine.
It's fine. Okay. I heard some hello voice from the.
Actually, that was my voice only. Actually, I was not able to
Okay.
hear you at the time. Might be that was my network problem.
Okay, but now it is clear.
Yes, sir. Yes, sir. Yes, sir.
It is clear. Okay. Thank you. Thank you. Thank you, Abhishek. So what is a thumb rule to design a secure system or trusted integrated circuit is that you should not leave any space for the don't care condition. You consider all the states, whatever the information is there, you consider all these states and design your system. In this case, you have to consider the remaining states for the user number 10 to 15. You have to consider that, and that will not allow to enter into your systems for the first design. And for the second design, if you are designing the system with the pin code of 3 or 2, then it is only for the 2 or 3. Do not leave any space for the fourth user. Do not leave any space for the fifth user or sixth user or sixth. Otherwise, it will try 2 or 3 times and it will easily crack your pin number, and that will be the hardware attack. Now, I think this is clear for the hardware attack point of view. Okay, what is a hardware attacks and what is a trusted integrated circuits? So once again, I'll tell you the two important definitions are here. The one important definition is for the hardware Trojan. The hardware Trojan means the intentionally if you add any hardware or any wire in a circuits, and that is for the malicious cause, then that is to be hardware Trojan. And trusted integrated circuit is an integrated circuit which does exactly what it asks for, means no more or no less than that is known to be a trusted integrated circuits. Now this term is very useful, that very unique, very common for the designer is to be a trusted integrated circuits. When the specifications are there for a some IoT system, then they ask used to design a trusted integrated circuit. Because in today's era, we have the IoT systems where the information is easily available. The sensor nodes are there. You can easily capture the sensor nodes and you can easily retrieve the information from the sensors. So to protect that sensors, that sensor design should be trusted integrated circuits. So now the new terminologies come up, that is to be a TICs, not the simple integrated circuit. The TICs are also there. The TIC means the short form is a trusted integrated circuit. That integrated circuits do not have any option for the hardware attackers to attack inside. Okay. If you have any query or if you have any question, you can interrupt in between the lecture. Otherwise, we'll continue with that. So we till now we try to understand what is the hardware attacks and what is a hardware Trojan, and how these hardware attacks and Trojans means change your hardware designing. And we have seen with the two examples. Now we'll see that key where this hardware Trojan can be inserted. The hardware Trojan can be inserted. This is a simple design flow, which you can see easily earlier in the system. The system specification, the first stage to design any VLSI system is to a system specification. Once we have the specification, we have the architectural design. From the architectural design, we have the functional design, then logic design, then circuit design, then physical design, and fabrications. So these are the stages, means these are the very rough design flow for the system designing. So where we can have possibility to hardware attacks, the system level specification we can have it change the specification so that your entire systems can be captured by the other user for the hardware Trojan, for the hardware attacks, architecture level or RTL level, functional level, the logic synthesis or gate level, circuit or transistor level, physical design or layout level, or design environment or tool levels. So this is a design level, the abstraction level. Now we can see, we will try to understand with the help of this IC supply chain. This integrated circuit supply chain means it is not possible to have a design centers and we have a fabrication units, we have the fabrication packaging units and testing units all at the same place. It is very impossible. It is impossible for any country or any system designer that they have the complete facility from the specification to the package or to the testing. So we have other locations. We have a location means we can consider if you consider in India itself, India mainly we have the design houses. They design the design the circuitry, but for the fabrication we are dependent mainly dependent to the TSMC, Taiwan, China, Malaysia, Singapore, Philippines, Vietnam. So these are the fabric. They have the fab labs. Major fab labs they have into the Taiwan. That is for TSMC lab. But it is very costly. So we can have we can have access to the Malaysia lab. We can have access to the Singapore lab. So we are designing our systems in India itself, but we are fabricating the same system in apart from the India. Then again we get the our packaged chip and we test that chip and we deploy that chip into the systems. So this is an entire chain of IC supply. So we have the specification, then design, then fab interface. Fab interface means the conversion of your design into the mask, that is to be your interface. Then you have the mask design. Then from the mask, you fabricate your design. Then from the fabrication, the wafer probing means you test the wafer, the dies and packaging. You get the dies and package that chip, package testing, and deployment. So this is a rough IC supply chain model. So in this supply chain model, I have presented I have used the three colors. The first color is green color for the few blocks, mainly for the specification, package test, and deploy and monitor. I have used the yellow color for design, fab interface, wafer probing, and dies and packaging, and have used the red color for the mask and flammers. This color's significance of this color is that the green color specify that the effect of hardware trojan, the insertion of hardware trojan is very less at the stage of specification, package test, and deploy and monitor. It is very less probability that the hardware trojan attackers attack at this stage, the stage of specification, because the specification means modify the modules or interconnects. If you modify the modules or interconnects, and if you design with the same specification, you can easily check. Once we test once you test your design, we have a multiple check your design, one multiple test for your design. You can easily identify that if there is a changes or there is a modification in the modules. But at the basic specification stage, it is very difficult to insert the hardware trojan. So we leave this phase. The second, we have a packaging stage. Once the IC is packaged, it is not possible to insert any hardware or insert any wire, extra pin or extra logic gates into the package. It is very difficult. So at this stage, very less chances, very less probability to have a hardware attack. And once you deploy and monitor, again, there is a very less chances for we have the hardware trojans and attacks. The second stage, the second moderate stage, we have the design stage. Design stage intentionally, once your design is finalized and you change the location of your wire, as we have seen into the first example, if you change the location of wire, so it is possibility that we have the trojan, hardware trojan in design itself. But the chances probability is less. Then we have a phase frame interface. The frame interface, again, we have the less chances. Wafer probing, we have the wafer is already there. So during the wafer probing, it is very less chances, and dies and packaging is very less chances. So we have the less probability at this stage design, fabrication, wafer probing, and the dies packaging. But we have a major hardware attack possibilities, major probability of hardware attacks into the mask and fabrication. Because you are not doing the masking and fabrication at your own. You are exporting that. Means you are sending your design to the Malaysia, or you can sending your design to the China or Taiwan. So there may be a high risk that they change the mask, which speed up the circuit aging. We'll see that term also. At the fabrication, at the time of fabrication, they add up extra wire, they're thinning your wires, or they can add up extra transistors, they can add up extra communication devices. As you can see in the pager attacks in Lebanon, they have a special kind of hardware. Means whatever the fabrication lab is there, they access that fabrication lab, they have changed an entire hardware design for that pager, and they insert a time bomb kind of hardware Trojan in that pager. And that networking is of around 5 to 6 years, not a minutes of time. It is required to be a long chain, long supply chain. Means you have a design, you send your design to the fabrication lab. The fabrication lab itself insert a time bomb kind of Trojan, hardware Trojan in your system. You package that and you send to the lab. When they have used that phaser with a specific message, phaser get blast because of that hardware time bomb kind of attack. So that is possibility. The maximum risk for the hardware Trojan at the mask level or at the fabrication level, because the major fabrication and mask level are exported by the system. Even though US don't have a much fabrication lab, they send their design to the TSMC for the fabrication. So major fabrication part is to be done by the TSMC, Malaysia, Taiwan, China, Philippines, and all are captured. Mainly all are captured by the Chinese companies. It is very high risk to have a hardware Trojan in that kind of system. We imagine it is a pager, but suppose you have some military equipment, and for that you require integrated circuits. And that circuit you are designing here, but we are fabricating that circuit, and they insert a location tracer in that. You heard advisory which is Indian Army is not to be used to be a specific mobile of Lenovo or some kind of mobiles, because in that mobile they have the hardware Trojan. That hardware Trojan continuously tracking their location and sending location to the remote access. So means there is a easily they can easily track the movement of soldiers from one place to other place. If there is movement of soldiers from one place to other place, they can easily identify with the help of that mobile. So you can see in 2022, after around the corona, the advisory is generated by the Indian Army for the Indian Army peoples that please do not use that kind of systems. They have the chipset of this. I don't want to the name of that chipset, but that chipset is not reliable for any user. So if you have the chipset in your mobile phone, then there may be possibility that that chipset is communicating with the device without your information. Means your secret information, your secret key is transferring from your mobile to the other systems. They can easily access your mobile. They can easily access your location. They can easily retrieve or they can get your data. So that is to be a hardware Trojan. So the main chances of hardware Trojan to be insertion and to be a masking level or fabrication level. That should be a debate, so that the government is pushing a lots of efforts. Now the government of India stopped sending of the defense and the army and the special chips to the fabrication for the fabrication in Taiwan and China. They required to set up their own industry, their own fabrication lab. The SCL Chandigarh lab is acquired by the ISRO. Required that are now fabricated SCL Chandigarh, 72 Complex Limited Chandigarh. So they have not sent their design to the China, or they are not sending their design to the Taiwan or even the Malaysia, Philippines, whatever countries are there. They're fabricating their countries. Same, the US wants to be start their own fabrication. They have started their own fabrication in Arizona states, where they have the world biggest fabrication lab. In India, the two locations in Gujarat and Assam, the fabrication labs are coming up with the Tata and the Vedantas. So the major part is that if you are fabricating your devices or your design with these countries, then there may be a chances of to have the Trojan in that. The hardware Trojan is there. The hardware Trojan means they can access their location. You can access your secret information, so you can easily identify your movement of soldiers, your special equipment, your maybe possible that your nuclear power energies, your nuclear locations, and so they can easily access that. So the fabrication and fablab. That's why maximum Israel is starting their fabric, because Israel is very means look at area wise is very smaller. So they started their fabrication lab in technologies. So they wants to be started their fabrication in India. So India is now considered to be a safe country for fabrication of this. There are lots of investments which are there for the fabrication because of the hardware Trojan and hardware attacks. because they need the defense systems, the ISRO system, the satellite system is required to be a trusted integrated circuit. If that kind of integrated circuit is having malicious activities of hardware trojan, then that is to be dangerous for the country itself. So that require this. Now, what kind of hardware trojan we can have in our circuits? So, as far as we have the functional type of hardware trojan means they change the functionality of the systems. So we have seen in the first example, I have started with the example of we can easily connect that example. So in this case, the function means addition or deletion of components. We have seen in the first example that there is a addition of the wires or the location change of the wires. Because of that, the functionality is modification. Functionality is modified, so that is to be a functional hardware trojan. That is not to be a functional hardware trojan. The second hardware trojan is a parametric hardware trojan. That parametric hardware trojan means damage the reliability or increase the likelihood rate of the performance values. Means the parametric, what kind of parametric hardware trojan means we have a thinning of wires. So you require to be particular thickness of wires. But if you put less thin wire in that circuit, then it will reduce the reliability of the circuits. Weakening of the transistors or the logic gates means we put weak transistors, weak logic gates, so that they can easily burn out, so that the reliability of the system is easily means a level, the low level. The modification of power distribution networks. So this kind of hardware trojan is known to be parametric hardware trojan. So majorly there are the two types of hardware trojan. One is a functional hardware trojan, which are the part of the circuits. Second is a parametric hardware trojan, which damage the reliability or increase the likelihood of the performance of the failures, like the thinning of wires, weakening of transistor of the logic gates, or the modification of power and distribution networks. What are the activation methods for the hardware trojan? As we have seen in the Lebanon pager attacks, the activation method is to be message activation. It is internally. It is not internally logic trigger. So we'll try to identify the activation methods for the hardware trojan. So one is a always on. The parametric hardware trojan is there. A parametric hardware trojan means if the wire thinning is there, the weakening of transistor is there, and modification of the distribution power network is there, then they are always on. They are always with the part of hardware circuit. So they are always on. They need not require to intentionally on or off that kind of hardware trojan. They generally change the reliability. They will not change the function. Actually, they attack on the reliability. They attack on the reliabilities of the system, not on the functionality of the system. So they are always on. Always on kind of hardware trojan is to be parametric hardware trojans. But the few hardware trojans are there that is to be event or signal driven. A particular event is occur. We suppose a temperature. At a particular temperature, this hardware trojan get activated, and they change the functionality of, or they can change your system of the or can completely capture your systems. So there are the two types of, one is the event or signal triggered. The event, it may be the sensor. If you can put an extra sensor in a circuit, that sensor sensing continuous monitoring your system requirement or system condition, and at a particular temperature or particular humidity, particular water level, it started, it activated. The second is a logical trigger. Logical trigger means you put the extra gates, and if the specific condition is occur in a system, then at particular specific location or condition, it triggers. So that is to be two types of hardware trojan. One is a sensor activation method, or one is a logic trigger activation method. It is clear. Sensor means you require to put extra sensor in a chip, and if we sense that condition, it triggers. The second type of is a logical trigger. Logic trigger means if particular function, particular state is there, then it triggers. That is to be logic triggers. Apart from that, the two categories, one is internally, one is externally. Internally means your circuit itself have a hardware trojan that activated with it either by the sensor, either by the logic triggered. And second is externally triggers. Externally triggered means from the outside the signals, you provide a particular signals, and the particular signals, it started activation. So the event signal, sensor logic, or internal external. Examples, as we have considered time bomb kind of attack that is occur into the major attacks, that is a time bomb, internally, and logic triggers. Logic trigger means internally the circuit is there, and a logical at particular condition, at particular time, they triggers. The trigger means at any time all the pages get blast because of that. They have the internal time bomb kind of hardware trojan. Then we have internally and logic triggers. We can use a temperature sensor triggered means if the system is reached to a particular temperature, then then the sensor get triggered and your system is captured or it hardware trojan will activate. So there may be possibility. Suppose you launching a satellite, and a satellite means we require at a satellite launching state we have a very high temperature. If you put a particular hardware trojan and the sensor, the temperature is reached to that value, this is start triggering. As is activated, it collapses or entire system. So that kind of system is to be a sensor, or it to be a sensor triggered kind of a hardware trojan. The second is a external signal kind of signal means user inputs, data inputs, environmental condition extra or externally environmental conditions or external triggers. Means external trigger means if you connect your system with the USB ports, it get blast or the hardware trojan get attacked. So that can be external signals. So the time bomb kind of is a very famous. Now it is famous word because of the Lebanon pager attack. It should be time bomb kind of attack that is internally and logic triggers. So these are the activation methods for the hardware trojans. Then next we have the effects of hardware trojan, effect or payloads of the hardware trojan. If hardware trojan activated, तो क्या होगा? Or what happens if the hardware trojan attack is occurs on the hardware? Then payload is the action or the damage that a hardware attack will do once it is activated. एक बार activate हो गया तो ये क्या कर सकता है? First, it change or control the functionality. आपके जो circuit है उसके functionality change कर सकता है, or it can capture a control, take a complete control of your system. Means now they control their own. So that is known to be a change or control of functionality. The example of this change or control functionality kind of effect is to be a killer switch, time bomb. The killer switch means a switch is there. If you trigger the switch, the entire device is collapsed or entire device is burned out. That is known. It may be triggered internally, or it may be triggered with externally, or it may be the sensor based, or there you insert a killer switch in your mobile, and if you activate that killer switch, it internally collapses your system. Complete system is dead or it collapsed. That is to be killer switch. Time bomb kind of attacks means at a particular time or event, the bomb attack is there. That bomb attack is again internally damage your system. So that is to be example of change control functionality, killer switch or time bomb. Leak sensitive information. It is very important. Because once your system is there, once you fit your trojan and once you kill your switch, once you kill your devices or the system which have the hardware trojan, that is not an impact. That is not very useful. That is not very useful or impactful. The main hardware kind of trojan which is impactful is a leak sensitive information. Means you have the hardware trojan is itself in your system, and it continuously leak your sensitive information. That is a very important hardware trojan, which mainly used by the Chinese companies. That is a side channel, means that is mainly for the power, timing, optical, thermal emissions, thermal and EM emissions. So side channels are there. You examine the power generation of the circuits, and you can easily identify what bit we are transmitting. With the help of timing, you can easily identify what information is stored in the memories. So that is for leak sensitive information. Reduce circuit reliability and lifetime. It is a very major challenge for the release designer, that the hardware trojan reduce the reliability of the circuits and lifetime of the circuits. The parametric hardware trojan drains source of power and the bandwidth of the CPU extra from the system itself. It reduces reliability. You can see that if you bought or if you buy a Chinese phone regularly, they will working finally for the 2 or 3 hours. After 2 or 3 hours, their performance get degraded because of the reducing the circuit reliability of the lifetime. Because they have the trojan, once the trojan is activated after a fixed interval time, the system reliability is very low. So means that force you to you have to buy a new phone. So once new phone you buy a new phone means you are participating in the economy of this market. So that is again a kind of hardware trojan that mainly used for the system. Nowadays we have nature to use and throw. Means use, we are not, it means we are not interested to repair that system because repairing is very costly. So instead of repairing that system, you buy a new system. If you buy a new system, means you are increasing the economic level. You means you are the part of circular economy. So that you are buying the system means you are again paying the GST and all this kind of taxes, so that the government economy will increases. So mainly, main intentionally, many companies it's put this kind of hardware trojan, that after a fixed period of time they suddenly drop their performance on their reliability issues. Then once the warranty period is over, the reliability drastically reduces. So that you have to change. You have no options. It is very difficult to repair that system. Means you have the option only to be replace the systems. Once you replace the system, means again for the 3 years, 2 years warranty is there, system working finely, but again the hardware trojan is there and it will attack onto the your systems and it change the reliability. So these are the effects and the payloads of the hardware trojan. The location where the hardware trojan can be present and the processing unit. So क्या होगा if the hardware trojan in the processing unit, it change or control of the system function itself. In a CPU, the hardware trojan is there. If the trojan is there, means in the controlling unit you have the hardware trojan, means it change or control of your system functionality, because all the process has to be done with the processing unit and processor itself having a trojan. So it changes control the functionality of the system. Second, memory structure. If you have a hardware trojan in memory structure, then alter the memory contents, monitor the memory activities, and leak the information. This is very dangerous, mainly for the ATM kind of structure, ATM, debit card, credit card kind of a structure. The memory hardware attacks are mainly used because they have the access of memory. Once you have the access of memory, they have the secret information of all about your credit, debit cards, your activities, your internet bankings, password, and all this information they have. They can easily capture that information. They can easily store their information, and they can easily use their information for the malicious cause or unintentional cause. So the memory structure, our group is mainly working in this memory structure hardware kind of attacks. So we are working in that area. Otherwise, they can have hardware attacks or hardware trojan and the IO devices. The control, modify, monitor the data communication between the chip and outside. If you have the trojan in IO devices, the communication device itself, you can easily uh, control or modify your data. The power supply units change the power supply current so that it cause the failures or leak the information, or it reduces the reliability of the systems. The power supply, if you change the power supply unit, then it changes the reliability of the system. Clock grid, if you change the frequency to cause the fault or failure, the timing side channel information leaks. It can be used to leak the information. So these are the locations where the hardware trojan will be present. Then how to detect these hardware trojans. So to detect this, so if we review, then first we try to understand what is a hardware trojan, then the example of hardware trojan, how the hardware trojan insert into the hardwares, then the location of hardware trojan, what is the cause of hardware trojan, what kind of hardware trojans are there. Now the last part is that key, how to test, how to detect this hardware trojan. If you have a hardware trojan in your hardware, so how to test, how to detect that hardware trojan. There is no clear cut or there is no perfect method is there to detect the hardware trojan, but the few methods are there. We generally use this method, that is the logic test based approach for the hardware trojan detection. So we'll try to investigate. So the logic test based hardware trojan. The first is the idea is that to run different test vectors. Suppose in a first example, you have a hardware trojan. So what you have to do, you have to generate all the test vectors, means all possible test vector from the user from the 0 to 15. And for all the 0 to 15 users, you have to check the password. If the passwords are same for all the user, means there is a hardware trojan. So you have to redesign your system. So that is to be run different test vectors and monitor the circuit output and behavior. White box, if the hardware trojan is triggered, malicious payload behavior will be observed. If the hardware trojan is there, then you can easily observe that key for the user number 10, the password is generated to be 100, means it is unauthorized user is accessing your system. So that is, you can easily detect that. That is to be a test vector generation. But full coverage test vector is impractical. Well, if the system is smaller, if you have a 4 inputs, means you have a 16 combination, 5 inputs means 32 combination. But if the system is having n number of inputs, then you have the 2 to the power n number of test vectors. It is very difficult to generate to test your system with the all possible 2 to the power n number of systems. For the large system, this is not useful, but for the smaller system, it can be useful. For a sequential logic circuits, if the n flip-flops are there, means you have to generate the 2 to the power n plus n number of test vectors. It is impractical to generate the 2 to the power n plus n number of cases, and you have to test your system for every input. It is impossible. Or the other idea is to random test with fail. Hardware Trojan are triggered by the random test vectors. Random test vector means the rare occurs events. They identify the rare occur events, and for that rare occur events, they trigger the hardware Trojan. So logic test-based approach is a simple. You generate all the test vectors, test your system, test your design for all the possible inputs. You check the outputs, you compare the outputs. If the outputs are working fine, then you can see that the system is hardware Trojan prone. But if the input-output relation is not as per your expectation, means there may be hardware Trojan, you redesign the system. But this technique is only applicable for a smaller system where we have a few numbers of inputs. If the number of inputs are very large, the sequential circuit is very large with the large number of flip-flop, then it is very impractical to use these techniques. Or apart from that, you can use a random test with test vector generation. Randomly you pick test vectors and generate and test your system, but it will not give you the 100% guarantee that the system is hardware prone. You can for extend or for a probability, for a fixed period of probability, you can say that the system is hardware Trojan prone. But if you are not test for the rare test vectors and the rare test vector occur, and that is a hardware Trojan that is generated by the hardware Trojan, means the system is completely failed. So this logic test based is mainly useful. Most of this industries using the logic test based test vectors. Sorry. Then scale-based, SCA-based hardware Trojan detection techniques. SCA is the full form is side channel attacks based hardware Trojan detection. Idea is to monitor the side channel information during the execution in the test time. Once before to launch your circuitry into the market, during the test time, you scan your device. Means you monitor the side channel information. Side channel information means the power requirements, the delay requirements, the your delay requirements. You monitor all the side channel information during the execution, and if they are perfectly working, means the possibility that there will be no hardware Trojan. Why it is work? The presence of hardware attack on a chip will show on some physical parameters can be observed to the certain side channels. Means if suppose you insert an extra gate, that extra gate consume extra power, so you can easily identify with the side channel power that there may be a Trojan. If you add extra gate, if you change the wire lock, it may be change a delay. So from the delay, you can easily identify that there may be hardware Trojan into the system. So that the idea is that to be monitor the side channel information during the execution of that time, and work कैसे काम करता है, because the presence of hardware Trojan on a chip will show us some physical parameters and can be observed to the certain side channels. Maybe capture non-functional hardware Trojan. जो फंक्शनल हार्डवेयर ट्रोजन नहीं है उनको कैप्चर कर सकते हैं, दैट मे बी पॉसिबिलिटी, मे हैव द हाई फॉल्स अलार्म, क्योंकि हो सकता है बिकॉज ऑफ फैब्रिकेशन वेरिएशंस, वी कंसीडर दैट द डिले ऑफ दिस वायर शुड बी दिस, but because of the change in the fabrication, the wire delay may change. So that can be a false alarm for the hardware Trojan. Measurement error भी हो सकता है, we measure this delay to be 2.2 nanoseconds and practically it may be the 2.119 nanoseconds. So it may be the measurement error to be there, or modeling error may be there. So the side channel attack based hardware Trojans are mainly used for the side channel information. The side means they are a parametric hardware Trojans are there. The category of this hardware Trojan is a parametrics. Now the power side channel means what? That is mainly used by the industry. That is known to be an IDQQ test. It's very famous test for the hardware Trojan attack detection. IDDQ and IDDT. What is the IDDQ? Measure the IDD. IDD means current at the constant states when the circuit is not switching and inputs are stable. Hardware Trojan will consume the leakage power. Means what we are doing here, that the system is in stationary condition. You measure your Q point current, the value of the Q point current, that is considered to be leakage current. You specify that for this system, suppose the leakage current is 9 nanoamperes. But if the hardware Trojan is there, so the hardware Trojan will also consume the power, and and it is not a 9, suppose it is a 10 nanoamperes. Then you can identify that there may be the possibility of hardware Trojan. But again, there is a possibility of false alarm because of the change in the linkage current. The linkage is also changed because of the aging effects. Once the system is of 2 or 3 year old, the linkage get changed, so that may be the false condition for the hardware Trojan. It's not perfect, but it can be used. It can use majorly. It can be used for the new system, where the design system just launched to the market, because before launching the market, we can perform the IDDQ test. The second is IDDT test. When there is a switching activities in the hardware circuitry, it will consume the dynamic powers. So the first is a leakage power, hardware Trojan. We can check with the leakage power. In the second case, we check with the dynamic power. Dynamic power means if the hardware Trojan is there, the hardware additional circuitry is there, that circuit is also needs power. It activates the power. The activation of hardware Trojan also needs the power. So you can easily identify that if the extra power is consumed by the circuit, means there will be the hardware Trojan. The limitation is that the false or small hardware Trojan are always on hardware Trojan. It is very difficult and sensitive to the noise and errors. Noise means for the environmental condition, there may be possibility that the leakage current may change or consume the less dynamic power or low dynamic power. Or over the aging, the test may be not useful. But for the initial state, these tests are very useful. There are very common terms that are maybe used for the circuit designer. That is to be IDDQ test and IDT test. Nowadays, it is compulsory that your system should be pass this test. Then only we can say that this system is to be trusted integrated circuit at initial stage. When we are launching our system from the system or getting the system into the market, so that should be passed with the IDDQ test or IDT test. Then only they can survive into the market. Then second is a delay at other sites and attacks, the path delay. 5 minutes more, na?
Yes, sir. Yes.
Okay. I'll try to finish in 5 minutes. So next we have the delay in other sites and attacks. That is to be a path delay. Path delay means the hardware Trojan can change the delay of the path. Means you have insert extra wires, or if you insert extra gate, or if you insert the extra logic blocks for the hardware Trojan kind of the killer switch. If you add a killer switch, then that will consume a delay. Means that required to be a pass through the circuit, and they have the path delay. The path delay may change, and this delay calculation can be used to identify the hardware Trojan. That is to be killer switch, means you add extra gate, that extra gate requires extra delay. You can easily identify that there may be a hardware Trojan is there. Or parametric hardware Trojan means delay change when the wire is thinner or get the rerouted. We have seen that in the parametric hardware Trojan attack, they have changed the thickness of the wire. If the wire thickness can be changed, means the delay can be changed. So you can easily identify that there may be a hardware Trojan. Or rerouting, as we have seen into the first case, where if we have the delay information of the X2 nodes or Z2 nodes, so we can easily identify that there is a change in the wire position. So there is a change of parametric hardware Trojan is there. The limitation of that, not all the path delay can be measured. The circuit is having 1,000 number of path delays. It is very difficult to calculate all the path delay, always compare this path delay. It is very difficult. And the fabrication variation and other noise. Again, there may be the fabrication variation unintentionally. In some places, there may be the thinning of the wires. So because of that, the delay can be changed. So these are the limitations. The electromagnetic emissions, the switching and hardware Trojan produce the EM radiation. The EM radiation can also be used to check the hardware Trojans. Test time approach, summary, if we summarize, the approach which we generally use to test or to identify the hardware Trojans are the logic test based approach, good for a small circuit, robust under the noise and variations. But the minus points are there, they cannot be handled the large hardware Trojan because we have to generate a large number of logic vectors. It is impractical, hard to generate test patterns and vectors. Second is a skin based or the side channel attack based approach. It is good for the large circuits, can handle the non-functional hardware Trojan, but the minus points are the sensitive to the noise and variations. Suppose you measure the delay, but delay may change because of the noise and variation. So you may have the false condition, false detection of hardware Trojan, or cannot detect the small hardware Trojan. If the small hardware Trojan means a single logic gates you insert a wire position you insert, it is very hardly it change the delay or hardly it change the leakage power. It is very difficult to identify the very small hardware Trojan. It is only used for the large hardware Trojan. So these are the two techniques which are generally used to test the hardware Trojan. There is a logic test based techniques mainly used for the smaller circuits, and the side chain attack based approach mainly used for the large hardware Trojans. But all have some good points and some minus points. So according to the designing of the circuits, you can consider this. The another technique that is to the runtime monitoring. The idea is to monitor the execution at the real time. Means when the system is launched in the markets, runtime means the system is under the process. You monitor the all the parameters. What is work? The hardware Trojan causes the malicious behavior. Behavior means we have the identical behavior. We all time compare this behavior of the system with a fixed number of input. Means during the processing of the systems, we generate the test vectors and we check the behavior. If the behavior is not finding a malicious and the behavior is actual behavior, then we consider that there will be a no hardware Trojan. That is to the runtime monitoring. Coupled with the interrupt mechanism, if you identify that there is a hardware Trojan, stop the execution once the hardware Trojan detect. Complementary of to the test time approach, it is complementary. 100% detection is not possible at the test times. The resource and the performance overhead. To insert extra time or runtime monitoring, it is required to have extra hardwares and extra. It reduces the performance of the systems. Monitoring unit take the resources. Effective for known type of hardware Trojan. If you know that this type of hardware Trojan there will be there, you can easily identify. Otherwise, it is very difficult for the unknown kind of hardware Trojans. So this is a summary for hardware Trojan detection. Parametering is good for the logic test. No, not good for the logic test. It is good for the power section attacks, delay, not for the runtime. For the big hardware Trojan, only the power section attack is useful or runtime is useful. For a smaller kind of hardware attacks, hardware Trojans, the logic test base is good, and delay section attack base is good. For tightly paced hardware Trojan means we are very consumed, very tightly fit into the system. Then we can easily identify with the logic test or power test or the delay section attacks. If loosely means they are spreading over the system, entire system is spread kiya hua hai, then it is easily to identify with the logic test and the delay section attacks. Always on, we can only identify with the help of delay section attacks. And leakage information, we can only identify with the power section attacks and runtime type of hardware. So the prevention techniques, so pre-synthesis is very simple here. To ensure the IPs are trusted before them use, formal verification should be there. Means formal verification means whatever the functionality is there, we have to check the proper functionality. We have to consider the don't care conditions. There may be a Boolean satisfiability and the unsatisfiability constantly should be there. Test and validation. Testing method we have to use, and hardware Trojan detection methods we must use. Post synthesis, once the synthesis is there, removal of dead space, we have to remove the dead space so that to prevent the direct hardware Trojan insertion and limit the big hardware Trojan. Circuit obfuscations make the reverse engineering tough, harder. Shielding of wires, prevent the EM radiations, interface protections, IP pins, internal module interface, power clock, skin chain, or control the hardware triggers. So that's all from my side, Sheikh. Any question about this?
If any participants have any query, they can ask in the chat box.
So go to the chat box. The topic is very vast. Actually, we have lots of things to cover.
But I think I'll share your email ID with all the participants, sir. If they have any query or any issue regarding the research, they will definitely contact you.
Okay, fine. No problem.
Right. So thank you so much, Vaibhav sir. Thank you so much for accept our invitation and being with us in this FDP.
Thank you, Abhishek. Thank you.
and this session will be definitely helpful for all the faculties and research scholars.
Yeah,
I
it is
hope.
very, very
Thank you so
interesting
much, sir.
topic. Is
Thank
now.
you.
Yeah, thank you, Abhishek.
Yes, sir. Yes, sir. Yes, sir. Thank you,
Okay,
sir.
okay,
And
bye
we'll
bye.
start. I request all the participants to stay here because we are going to start the last session of this FPP. So I request all of you to stay here. Thank you. Zia, you can start the session.
A very pleasant evening to everyone. Welcome back to the last session of Atal Online
रिकॉर्डिंग चल
Faculty
रहा है
Development Program.
तो
As
रिकॉर्डिंग
the
शुरू हो
guest
गया
for
है
this evening, we have amongst us Dr. Durgesh Nandan. Dr. Durgesh Nandan is a distinguished academician with a strong foundation in VLSI, having earned his
वायर का
PhD from JP
वायर
University of
वायर
Engineering
कौन
and
सा
Technology. He has garnered significant
नेट का
recognition for his research contributions, including the prestigious JSS Fellowship and awards like Young Personality of the
वही
Year
ट्रेन
Award
वायर हुआ है
and the I2OR Preeminent Researcher Award. His professional journey is multi-faced,
नहीं
encompassing roles as the guest faculty, research
कर
mentor,
रहा हूँ उस पर
industry professional, and academic administrator at Symbiosis Institute of Technology and currently at the SR University as an Associate Dean of Research and Associate Professor. This diverse experience provides him with a unique perspective and valuable insights. A prolific researcher and author, Dr. Nandan has published extensively in renowned journals and conferences. He is also a recognized intellectual property expert and a dedicated mentor to aspiring entrepreneurs. His research interests are wide ranging, encompassing key areas like computer arithmetic, signal processing, and the emerging fields of AI and IoT, making him a significant contributor to these domains. We wholeheartedly welcome you, sir. Now, I would like Dr. Durgesh Nandan, sir, to please take over the mic.
Thank you, Jia. Thanks for introduction.
Thank you, sir.
Sheikh sir, can I start?
Yes, sir.
Uh, Kindly once confirm my slide is visible.
Yes, sir. It is visible, but it will be better if you'll first make a full screen mode and after that share that window.
Okay, I will do. Don't worry. Hopefully now it's in full screen mode. Am I right?
No, no, sir.
Now?
Sir, you just first stop the sharing your PPT first. Yes, sir. Now you made your PPT full screen. Okay, and now come to the window of the Google Meet, and now share that entire that your window only
हेलो सर
window of the PPT.
सर मैं बंद कर दूं ना रिकॉर्डिंग हाँ ठीक है हाँ ठीक है सर
Now it's confirmed.